excited to make this video because I've been teaching this idea of using proportions to figure out wildlife populations for years, and students often have trouble setting up these proportions themselves without this sort of proportion as a guide, you know, the number of tagged animals in the recaptured sample to the total number in the recaptured sample. Without having this as a sort of a guide, it's sort of hard to know how to set up the proportion on your own. And I've never quite understood why, but I think I figured out a way to make it easier as I was thinking about making this video a minute ago. So we'll use that idea in the video, and I'll certainly teach it when we do the lesson in class. And it's actually pretty simple, so I'm surprised I never thought of it before. So number 4 is the hardest problem on your homework because it's not the standard problem where you tag a certain number of animals, and that's the number of tagged animals in your total population, and then you recapture and count the number of tagged to the total number of animals in the recaptured sample, and you use those numbers to try to figure out the total number of animals in the population. That's the typical scenario. That's the one that's more based on the more real-life scenario where you'd be trying to estimate the total number of animals in the population, and so that's what you do on problems 1, 2, and 3. On problem 4, it's a little bit of a different setup, so you've got the same proportion, but the unknown is different in this scenario. So let's read it. A wildlife preserve believes they have approximately 1,200 wild horses, 1,200 wild horses on their land. So they believe their total population is 1,200. So I'm actually going to start setting up the proportion right now. They believe the total number of animals in their population is 1,200. So that's actually the number that we're usually solving for. They round up 15 horses and humanely tag one of their ears. And so that's the number of tagged animals in the total population, 15. And the difference that I thought about before the video is from now on we should write the units. So 15 tagged to 1,200 total. If their estimate of the population 1,200 is correct, and they later corral, so here's the key word later, so this is our recaptured sample. They later corral 160 horses. How many of these horses should be tagged? So our ratio of tagged to total in the recaptured sample should be equivalent to our ratio of tagged to total in the total population. And so I feel confident that putting tagged in total is going to make these proportions easier to set up without having to use this as a guideline. So later they corral 160 horses. That's the total number of horses in the recaptured sample. We want to know how many of those horses would be tagged. So that's our unknown X. I'm going to ask you to solve that during the pause, but before you pause, don't forget that there's another question here. What could the wildlife preserve do next time to improve the reliability of their estimates? So see what you get for X, give some thought to the reasonableness of that number and the way they did their tagging and recapturing, and see if there's a way you could improve on their method. Just as a hint, you could think about some of the things we discussed today when we did this similar scenario using the goldfish. So pause now.
Paused.
Okay, I look at the 160 and the 1,200. I don't see an easy scale factor. 15 and 1,200, there might be an easy way to scale 15 up to 1,200, but nothing jumps out at me as being extremely easy. So I'm just going to set up a cross product equation. 1,200 multiplied by X is equal to 160 multiplied by 15. 160 multiplied by 15 is easy because it's 10 160s, which is 1,600. And 5 160s, which should be half of 1,600 since 5 is half of 10. So that's 2,400 for my product. 2,400 is equal to 1,200x. If I want to know what x is, I don't want 1,200 of them, I want one of them. So I undo this multiplying by 1,200 by dividing by 1,200. And then I need to do the same thing on the other side of my equation because of the property of equality. And so the 1,200s cancel. I get 1x, which is x. And then the quotient 2,400 divided by 1,200 is 2. So the answer to the first question, how many of these horses should be tagged? The answer is 2 horses. The second question, what could the wildlife preserve do next time to improve the reliability of their estimate? That question implies that there's something wrong with the reliability of their estimate using their current method. And so if you think about their current method, they think they have 1,200 horses. They tagged 15 and sent them back out into the population. When they recapture 160, which is, more than a tenth of the population, but not much more, they would expect 2 of them to be tagged. Now the problem with expecting 2 to be tagged is if you expect 2 to be tagged, one is very likely only 1 will be tagged, in which case your estimate is off by half. Or 0 could be tagged. It would be if you only have 15 tagged horses out in this population of 1,200, you can capture 160 all you want, but they're very likely that none of those 15 tagged horses will be in that group of 160 horses. So if you get 0 tagged, it looks like your population of horses is actually infinite, which of course is unreasonable. And you might end up getting like 4 or 5 back tagged, which throws off all your estimates. So really there's a couple ways they could improve on this. The most obvious and probably the most straightforward way would be to tag more horses in the first place. If this 15 was, 40, then you get a much more reasonable estimate. When you recapture 160, you should expect some of those to be among the 40 tagged horses. Another thing you could do is you could tag 15. I still don't think that's a great idea, but if you're going to tag 15 and you're going to recapture 160, you better recapture 160, send it back out, recapture another 160, send it back out. To do several trials. You either want to tag more animals in the first place or do several trials, or maybe both of those things to improve the reliability of the estimate. Okay, I hope that helped with the homework. I'll see you tomorrow.